Alright, let's go. Let's solve some LeetCode problems, man. I was on to. Should I do hash maps? Okay, I started two pointer square of a sorted array. I had put a lot of thought into it, and I even tried to see the solution. Though I saw a little speck of the solution, I took a little hint. And let's see. See, in the solution, he said that when we square the array, right, the maximum numbers are at the boundaries. So for the arrays, it's 4 minus 3, I think it was minus 3, or I think it was minus 1, 0, 3, and 10. So when we square it, we get 16 minus, 16, 1, 0, 9, 100. And he said that what we will be doing is either this will be the maximum number or this will be the maximum number. So we compare, is this the maximum? No. Is this the maximum? No. Okay, then we, is this the maximum? Yes. If it is indeed the maximum, then we move j to here. Okay, then we know we have I still here. Then we go 1, 0, 900, and j is here. Is this the maximum number or is this the maximum number? Okay, this is the maximum number. So we give its position. We'll give this the position. Then we will have 1, 0, and but isn't it same as what I was doing? Okay, let's. Do you still wanna try 100? 1, 16, 100. Okay. So we have I over here and j over here. Is this the maximum number or is this the maximum number? Indeed, this is the maximum number. Okay, if this becomes a maximum, then I should increment it, right? Should should give its value. Okay, if this becomes the maximum, then we swap it and we check it again. I think that is the for this array minus 3, minus 2, and minus 1. I square it, then we get 25, 9, 4, 1. Okay. So I say, is this the maximum or is this the maximum? I say that this is the maximum, therefore we swap it. 9, 4, and 25. Okay. Then j comes here. Then we compare again. Is this the maximum or is this the maximum? We'd say, okay, is this the maximum or is this the maximum? This is not the maximum. This is not the maximum. Okay, see, in this case, when I had 16 with 100, I moved it here. 9. Then I should have moved it. Okay, but we compare first. We compared. Is this the maximum? No, it is not. Okay, after swapping, I have to compare it once, right? So we go compare I and j. If nums of I, right, is either if it is less than nums of j, if it is less, that is this number is smaller, then we simply go j minus minus, and we move j to the left. Then we compare again. Then we compare again. I is not being touched. If 1 is less than, is 20, is okay. Is I less than? No. Else if the condition will be is okay. Automatically, if it is not less than, if it is not less, if this number is not less, okay, I'll check afterwards. Though I do have WhatsApp. What are you looking at, dude? Nothing. Okay. So we go with, if it is not the maximum, then obviously uh, else shit, else, see, if I, that means the position at I is greater, right? The position at I is greater, right? Else the position, else if, I think I should check else if case. Right. Else if n of I is greater than n of j. It seems stupid, I don't know. Okay. If I, okay, if I is less than, I is less and j is greater, right? I is less and j is greater, then we, I is less, that is position at I is less and j is greater, then we simply okay, I is less and j is greater. If I, see here, I was greater and j was less, so we swapped the position. Either this will be the greatest, either this will be the biggest, right? So when I was greater than j, then we swapped these position. Okay, either this will be great or this will be great. We swap these positions, and I moved. Okay, if I is greater than j, then we swap I and j, right? Then what we will do is decrement j and check this condition again. And if I is less than, okay, if I is less than j, if I is less than j, is I less than j? No, right? Okay, else we move I to the left. Okay, so if I is less than j, if I is less than j, I, is it less? Okay, if I is less than, okay, first let's see, let's take this example. We will consider both of these examples, 16, 1, 0, 9 and 100. Right, so first we'll have I here, j here. I check, is I less than j? No, I is not less than j, so I moved j here. Then we check again, Is I greater than j? Yes. Okay. Yes, I is greater than j. Then we swap these values. Here we go. I get 9, a 1, a 0, a 16, and a 100. Then I check again. Here's I, and I have and j. Then uh, is I greater than j? Yes, the I is greater than j. Then we swap. We get 0 here, 1 here, 9 here, 16 here, and a 100 here. And j comes here, I is here. Is I less than j? Is I less than j? Yes, I is less than j. So we put I and j comes here. Okay, then let's try to do the second. I get 25, 941, 41. Okay. Is I less than j? No. Ooh, dude. This would okay. So I should first check, is I greater than j? Is I greater than j? If I is less than j, it is not less. So it should have. So I would need to check, is I greater than j? If I is indeed uh, greater than j, then we swap and we move j here. Okay, so we get 1 I here. I get, what the fuck is this shit now? Okay, I get 1, 9, 4, 25, and my j is here, and my I is here. Then we check again, is I greater than j? No, I is not. Is I less than j? Yes, I is less than j, so we move I. Is I less than j? Yes, I is less than j. If we decrement it, then it would, but I need to. Okay. Now, if I again check here, is I greater than j? No, it is not. So, is I greater than j? No. Is I less than j? Yes. Uh, okay, dude. Let's take a look at the solution.
Hey guys, Greg here. Let's solve squares of sorted array, LeetCode number 977. So we're given an integer array of nums, and it's been sorted in non-decreasing order. I hate
Yup.
if for key is use the same row. Have here is our squared numbers. The easiest way to solve this problem, kind of the brute force solution, is just to say, okay, well, we have the numbers. Why don't we just sort it? We can do that in big O of n log n time. You know, it's not the worst runtime. And it would immediately sort it. You could do this in place you'd want. Squares and try to beat n log n. So if you're trying to... Now, they're not already in sorted order, but they actually have this kind of clever property to them, where your biggest values are going to be on the outside. So we'll say that we're building up a new array, and the first value will be the biggest value, which is 100. Now, we're actually just going to slide this over here, which is why we call this a two-pointer approach. So we're basically using 2 pointers that are tracking these different indices here. They're really indices. And now from this point, your biggest value is either this or it is this. And by the way, I'm going to call this index as L for left and this index as R for right, or index or pointer. We really mean the same thing here. So we have our 2 pointers L and R. Our biggest value must be either the array at L or it is the array at R. It happens to be the array at L, and so we are going to kind of plug in that we have that value there. That is our second biggest value, and we move L towards the middle here. We have again that our biggest value must be one of these two, either the array at L or the array at R. r, it happens to be at r, we're going to plug in our value here. And so we'll move
Okay.
r over to the middle. Our biggest value must be one of these two. It happens to be L. We're going to move L towards the middle. And then we would say, hey, we have that they're equal to each other. So we are going to get our new biggest value, which is equivalently our smallest value at this point, because we are actually at the end of the array. At least we've used all the numbers. And here, it doesn't really matter. If your values are equal to each other, we actually have that the array at L is equal to the array
So
at
they're
R.
using
And that could have happened at any
external
stage. That actually could have happened if this was a
extra.
16 here. If they were, and say R was over here and L was here, it doesn't actually matter which index we used. So if R and L pointing to the same value, let's say, for example, that we just moved L over, it doesn't really matter which index we used. Either way, we're going to run into this scenario where R is now not really named appropriately, because R for right is actually on the left. So as in, they've kind of done this crisscross thing that we no longer have that L is less than R. And more specifically, we no longer have that L is less than or equal to R. We have that L is strictly greater than R here, meaning they've kind of done this crisscross thing. They've passed each other. And so this is kind of where we're going to run our while loop condition. We're going to run this while L is less than or equal to R. We're going to build up this array here. Now, I'm sure you've seen the only problem that we have is that these are actually sorted in the wrong order. But to just flip around this array, you can flip around this array in O of n time. You can actually do it with a two-pointer technique I encourage you to try. Okay, so let's write our code. We'll get left. That's basically our capital L here. So we're going to set that to be the first index, which is located at index 0. We'll get right, which is our capital R. That is going to be equal to the last index.
Okay. So
X, which is going to be located at the length of nums minus 1. And
then
then
an
we'll build
extra
up this
array.
result array. And so this
Okay, so they're building an extra array, which I didn't thought of. So left equals 0, right equals len of nums minus 1, result equals to empty array. Then we go while L is less than, or well, n is less than equal to R, less than equal to R, we go if nums of L is greater than nums of R, if left side is greater, if this is greater, then we move the left pointer. We say result dot append nums of L, and I move it left, else that is greater, and I go result dot append nums of R and R minus equals 1. Then again, let's flip these value while I just have to swap these values while okay, L equals 0 and R equals nums of length of nums minus 1. We go well, L is less than equal to or R. I go that result of, I'm just constantly swapping, temp equals result of L, result of L equals result of R, and result of R equals temp L plus equals 1, R minus equals 1. Then in the end we return the result. Let's try. Okay, I didn't square it. Yeah. Okay. um I in range 0 comma r plus 1 we go nums of I equals nums of I times nums of I. Let's try this. Okay, output was this. Okay, let's forget about flipping. Let me just okay okay, whatever the bigger value is, I swap that. Right, let me take a look at result. Is it flipped? Right, yeah. Okay, so it has flipped completely, and then all I have to do is reverse it. How can I reverse a string? See, it is comparatively easy, I think. Reverse to reverse a string, or reverse a simple character that we have 0, 1, 2, 3, 4, 5. I swap these values 5, 2, 3, 4, 1. Then I move it here, move it here. Then I again swap these values. So that's exactly what I did, right? L equals 0, R equals nums of I minus 1. Length of nums of I minus 1. Then we can check, well, L is less than equal to R. While L is not equal to R, I will simply go, we swap these values, so nums of I right. This seems to do. Now I need to reverse it, flip it exactly. I increment I and decrement j. Swap these values. Okay. Okay, let me see. I swap. I get I here. What in case of 1, 2, 3, 4? We got I. We got j. Swap. 4, 2, 3, 1. I j. Swap. Then this goes here and this goes here. Okay. Then why didn't it work? Dump of I, oh, right, L. Nums of L equals, because I'm using nums when I should have used result, because I'm flipping the result array. Okay, first this list will store R. What will it store? This list will store our resulting array. Then square the nums array. Okay, so what we basically did is we found the largest element, and according to the whatever the largest is, we put it in another array. Okay, well, I could not, maybe I would have, but it is good to know all things, and you must revise as well. Right, okay, square the nums array. Then we go here. Then I go swap equals to result of R, and result of R equals temp. Then left should be incremented by 1 and right should be decremented by 1, and I think it should work. Yeah. Right. 18 millisecond, but okay.
This is going to be initially built in the wrong direction. We'll actually reverse the order at the end, but that's fine. We can even do that in place without any extra space. And we can say while we have left is less than or equal to the right. Well, if the absolute value of nums at the left, if that absolute value is actually bigger than the absolute value that is
Also
at
use the
the
square,
right,
but this
well, that
is
means we
the
want to
yeah,
use the left
okay.
one. We'll result dot append the nums at the left, these squares to the center. Otherwise, we're in the opposite case, or they are equal to each other, and so it doesn't really matter what
Okay,
you
so
do
we are
if
doing
they're
two
equal to each
operations
other.
in one.
So get that squared value on the right, and right is going to go down by 1 to again move toward that we reverse, and then we can just return the
reverse?
result because it's now been reversed. If we run that, that should work just fine. Every single time we run this, we are
Okay.
either moving left or right towards each other, and this loop completes once they crisscross. So basically, you're going to go through all of the numbers, hence we have all of the numbers in the result. Then that is going to be an O of n thing to do, where n is the length of the numbers. After that, we have to reverse, which is going to be O of n time as well. You basically just reverse it in linear time. There's actually a 2-pointer way to do that if you wanted to write it yourself, and then you can return the result. So ultimately, this is going to...
Okay, so we can perform two operations at once. Instead of squaring the array, we find the largest of the largest element of the 2 pointers and add the square pointers. Then we add the square in the result array. So I can check for absolute value, and absolute value of a, then we will return the square left, right. Okay, then we can call the reverse function on this array and simply do this, right? Okay, then reverse the reverse the array. Then we reverse the array to reverse the array. Hey, then can't I find the smallest? No, because the property says that the largest element will be at the end. Okay, then reverse the array and return it. So we submit this and we get, okay, milliseconds. Let's try to do the same in C++. We have a vector. Okay, I want to reference Shane C++ bugs C slash okay, where are the standard algorithms? Dynamic memory tools, copy control, template programming, specialized tools and techniques. Is the algorithms algorithms for the SGL. Where are the algorithms for SGL? Algorithm. Algorithms to copy. Swap. Hmm. And algorithms relational operators lambda using library function with algorithms. Okay, plus arithmetic plus minus negate. This callable objects functions defining a base class and query evaluate. Algorithms. A brief tour of the algorithms. Yes, A70. Library name and headers. 870, right? Okay, a brief tour of beginning and end. Okay, find simple find algorithms. Can I have sorting algorithms? Beginning and search. Other read-only algorithms for each mismatch. Binary search algorithms. Found algorithm at right container elements. Fill generate. Alright. Rhythm with swap. Replace algorithms with bidirectional iterators. Partitioning and sorting with algorithms. Yes. Okay. What's partition, copy, partition, sorting algorithm? Alright. These algorithms require random access iterators. Each of the sorting algorithm provides two overloaded. Okay, sort. I want to sort. One version uses the elements operator. Okay. Compare. The other takes an extra parameter that specifies the ordering relation. Okay, so I can use sort, order, and then compare. Okay. So we will go with a integer left equals 0, then integer right, which is nums dot size minus 1, and then I will create another vector of int result, which I will yeah, I don't need to do anything with that. So while left is less than equal to right, we will go if absolute value of left is less than absolute value of right, and we go result dot append power of right. If I'm squaring L2, okay, not else we go and okay, better to use brackets. Okay, and I want to increment L by 1. Then in case of result dot append power of right comma 2 and decrement right. Okay, then I want to sort result dot beginning. Can I provide beginning partial sort, generaling, reordering? Okay, beginning result dot begin and result dot end. I hope that's how the iterator works because I have no idea. Let me check my what is what is it do I have to check? Okay, GitHub. Well, bring it here. Okay. I want to go to Shane. Let me. There we go. CPP. Feel like I can vector. Yeah, iterator, vector iterator is. Oh shit. Ah. Okay, yeah, iterators. Okay, vector dot begin and vector dot end. Right, nice. Then I can sort it and simply then okay, this bracket is for the while loop. Ooh. Right, this bracket. Then we sort the array, and then this is for the function. We return it wants a vector, so I can just return result. Let's try and run it. Okay, compilation result dot append. Yes, it uses pushback. Pushback. Okay, yeah, okay. So something was not right here. Where did the 4 come from? Okay, we squared if absolute value of left. Sorry, yes. That is on me. Nums of left and nums of right. Nums of left and nums of right are squared, and that's how we get it done. Yep, great, works great, nice. Okay, so done with the first exercise. I think the second is easy as hell. Reverse the string. I just did. Okay. We'll start with Python. Do not return anything. Modify s in place instead. All right. Okay. So write a function that reverses a string. The input string is given as an array of character s. You must do this by modifying the input with O1 extra memory. Okay, that's really easy. Printable. Let me just say write a function s. So start with left equals 0 and right equals len of s minus 1. We go while left is less than equal to right. I just swap these value s of l. Just swap these values. See, it's really easy. I think right. I had done simple swap operation. Whatever this like. Let's take Shane. We put I here. We put the J here. I say swap. We get E, H, A, N, and S. Then I move I and move J. Then I say swap. Then we get E N A H S. Then I have I here, J here. Is I less than or equal to? Yes. Then I say swap, but swapping won't even make any difference. They move crisscross, and now this condition is invalid. So we go down to S, then I'll go S of L equals S of R. S of R is equal to temp, and then I say equals 1 and write as minus equals 1. Then do not return anything. Right. Let me try and run it. Yeah. So there we go. Got this right. Okay. I hope this is the right solution, but let me see the video solution for this.
Hey guys, Greg here. Let's solve reverse string, LeetCode number 344. It's a classic and probably the easiest two pointers problem. So we'll write a function that reverses a string, and the string is actually given as an array of characters S, and we'll see why in a moment. Now you must do this by modifying the input array in place with O of 1 or constant space extra memory. So if we were given the array of the characters H, E, L, L, O, you'd want to reverse that in place, meaning that all of these spots, they are going to be just adjusted to be what it would be reversed. So now it is O, L, L, E, H. So what we mean by in place is that you cannot return this solution. You can't just return S and then : -1. This in Python will return a copy of the reversed array. So if we were to run that, it's not going to like that at all. And it actually thinks that our output is precisely the same as it was before, because it's actually not looking at the thing we're returning. It says, don't return anything, modify S in place instead. So no matter what we return, it actually is always going to look at just what the underlying memory is of this S. So say that we are given the array of characters H, E, L, L, and O. Again, what you're not allowed to do is just to make a copy of this thing and then to reverse this copy. So you could make a copy and then you could actually just return the opposite, which would be this. Except that no matter what, that is still changing this copy here. And so we're not interested in changing that. No matter what our solution is, we must be overriding this array right here. We have to change this block of memory. Okay, so the way to do this is to do a two-pointer approach. Because we're trying to reverse the string, let's make a pointer L point over here. That's actually just going to be an index at the beginning here. And we'll get one R that is going to point at the end, which is going to be n-1, n is 1, 2, 3, 4, 5 here. So R is going to be 4. Now, before you get annoyed that I'm saying two pointers instead of indices, yes, if you're using something like C or C++, pointers mean something different, but this is just the way it's called. This is called a two-pointer approach. So if this thing was called S, then we could access the character on the left of S at L, so that's going to be this character. And we could also access the character on the right, which is S at R, so that's this character. And then really, you just have to swap them. And in old languages, you had to make like a temporary, where you had a temporary variable looking at one of them. But in Python, it turns out you can actually just swap them very easily. I'll show you how to do it in code, but you would just straight up swap them. So you would put the O over here and the H over here. Now that those are swapped, we need to move these over. So we would
I think I know how to swap them. I would say S of L, comma S of R equals S of R, comma S of L. I guess that's the new way. Yeah. Simple swapping. There we go. Okay. So, do you see a single swap operation made such a difference? Swapping.
do L increments and R decrements, and
Okay.
we would do the same thing here. We would be looking at these indices, and we would just swap them. We would move the L and the E over. This is going to be L, this will be E, and then when we get to the middle here, that is when our algorithm is done. And just to color it better, I'd rather it looks like this, but the point is that you actually can complete this algorithm as soon as they're equal to each other. Because, I mean, if you wanted to, you could swap S at L and S at R, but they're already equal to each other, so there's no point swapping them. At this point, when they're equal to each other, the algorithm is complete, and you can see that we swapped the underlying memory. Okay, so we'd get our index L is equal to the first index, which is 0. We'd get R is equal to n minus 1. So let's also get here an n is equal to the length of the S array, so that we can get R is going to be the last index at n minus 1. And then we can just run this while L is less than R, because again, as soon as they're equal to each other, this would complete here. So while L is...
Okay, so one point is I should update it to while L is less than R. Right. While it is less than R. So because at it becomes equal, so we don't need to. If it crisscrosses, then even it is a point. Right. To
less than R, we
less
just
than
want to swap them. And you can do it like this quite easily. You just set S at L and S at R to equal S at R and S at L. In Python, this just sets S at L to be this and S at R to be this simultaneously in a way that it doesn't mess things up. It simply swaps them. Okay, and the only other thing we have to do here is to make sure that L is going to go up by 1 to
And
move to
R.
the right, and R is going to go down by 1, moving that to the left. And that is actually the end of our algorithm. We don't even have to return it because we're not returning anything. We're just modifying the array memory. Okay, so let's look at the time and space complexity. So the time complexity, we're really just going through the array. We're using two different variables. One is going to the right, one is going to the left. And when they meet in the middle, then that is when it completes. So we're basically just going through the array or the string. And so that is going to be big O of n. And as we already explained,
no space O of 1.
No extra.
Okay, let's try to do the same in C++. I think there is a reverse generic reordering, rotate, reordering. Yeah, using bidirectional iterators, I can reverse. Because these algorithms process the input sequence backward, they require bidirectional iterators. Reordering. Okay. Reverses the element in returns in iterator, just pass the element copied to the destination. Permutation algorithms. Random shuffle. We have random shuffle. I cannot reordering. I cannot reverse. Okay, require bidirectional iterators. Where do I have bidirectional? Do strings have bidirectional iterators? I don't know. Alright. Okay, let's do it the old-fashioned way. R equals 0 and int of R equals s dot size minus 1, and while L is less than R, I go auto temp equals s of L, right? Then s of L equals s of R. Don't forget this, and s of R equals temp, and that is all. Oh, sorry, my bad. Yes, I know. Plus plus or minus minus. Right. Okay. Great. So that's how we get this done. Right. Memory. So I could do it. Okay. Great. So I'll leave today. Sorry, we got 2 problems done. Let me update this. Okay. down to 10 problems. Nice, I've covered 1/10 of the part. Okay, so